the south. So when you move to the north, you pour water. As the water goes to the north, it rotates clockwise in the north like a clock. South, it rotates clockwise. Equator stop, no rotation here. So we go some few meters away from the equator. That is 10 meters both sides. We finish on the line. So let's move to the north. 10 meters. So this is 10 meters north, whereby the water rotates clockwise like a clock. And the sticks here, these are the indicators which shows how the water rotates. So you can see the indicators are turning clockwise as the water goes to the north, like a clock. So the force is Coriolis force. So the same thing happens when you flush a toilet and when you open watering taps. And the far we move away from the equator, the faster the water rotates. The near we move toward the equator, the slower. When you look at the bottom here, you can see as the water comes here, the spiral going this way. So when you go to the south, they spiral the other way. So this is what happens in the north, clockwise. When you go to the south, it changes to the other way, and clockwise. Okay? Now, we are moving to the southern hemisphere and see what happens. South, it goes the other way, it's clockwise. And that's how we differentiate between north and south. Coriolis effect. So now we can go to the south. Let's go to the south and see what happens. Now we are moving to the south. Southern hemisphere. Whereby the water rotates and clockwise. This is the south. It's the south. Whereby the water rotates and clockwise. The other way. Let's see. Look at that. See the difference now? So this is how we differentiate between the two hemispheres, the north and the south, and clockwise. Look at that. Let's look at the bottom also. See also the spirals spinning the other way. So when we get exactly on the line, you find that no spirals, just the water go very straight. So this is how we prove that we are on the southern hemisphere. Now we are moving exactly to the equator and see what happens. Even if we try to make the indicator go the other way, it can't. It goes to the normal direction. Look at that. So that is southern hemisphere. Now let's move to the equator and see what happens exactly on the line. Going up zero, where I told you here, no rotation. So what happens here, because we are at 0 degrees, no rotation. This force and this force, when they meet here, they balance it. So here, very straight. Now we show that here, right over. Look at that. No rotation. No rotation. Let's look here. Let's look here. Very straight. So this is how we show that we are exactly at the equator.